All right, so today I'm going to be talking about creating an impact with AI and avoiding what I've seen to be one of the biggest misconceptions about the space, and especially on how technology is being developed in this space. Um, so I like to start this talk just observing an important slide. And so what this slide shows is our population from essentially when we became humans over 12,000 years ago to today. And as you can see, much of our history, much of our timeline has been at very low populations, just about 4 million people. And then something crazy happened in the last couple centuries, like the last 2 centuries. We actually had an explosion in growth of our population. And with this growth in population, I think it's incumbent upon all of us to strive to create benefit for this world, to really think through some of the challenges we have with technology, the challenges we have with AI, to understand how we can continue to thrive. I'm going to revisit this with some nice perspective. So I've been working in this space for quite some time. So my wife, Lingjia Tang, and I were both faculty at the University of Michigan. We run a research lab together. We've done a number of really cutting edge pieces of work. And we've specialized in artificial intelligence as it scales to millions and billions of users. And with this, of course, we published a lot of papers, but we wanted to take it to the next level. And so we've been doing just that. One of our most notable contributions early in our academic career was the creation of what we called Sirius. Of course, we launched it as Sirius, which was an open source conversational AI that also did computer vision. So you can, hold the AI up in front of the Eiffel Tower, not say it's the Eiffel Tower, and ask questions like, well, what is this building and why is it so popular? And the AI would tell you it's the Eiffel Tower. So we created that open source. Apple sent us a letter. They were like, we love what you're doing. It's awesome, but the name is a little bit too close to Siri. And so we ended up changing it to Lucida. But after this, after working at academia, we went on a journey to bring this kind of technology to market through commercializing what we believe to be the next generation of tech. And at the time, if you look at conversational AI, if you look at NLP, there's been a massive disruption in the space. For many, many decades, natural language processing was reasoned about as computational linguistics. And that computational linguistics approach that predated deep learning, that predated machine learning, and really what is the foundation of how we do AI today, that approach is one where you really create these structures out of the language, right? So you can reason about the grammars of a language. You've got noun phrases, verb phrases, nouns, verbs, adjectives, and so on. And you can build these things called parts of speech trees and other kinds of rules-based data structures on the language. Up until around 2012, this is how these systems worked, by and large. And there was a disruption that came from academia, and that's with the introduction of deep learning into how we do these things. It turns out that when we as a child learn language, we don't know what nouns, verbs, and adjectives are. I've got a 6-year-old at home, and he is incredibly capable of understanding everything I say. He doesn't yet know what a noun is. What he has in his head is a neural network. And what that allows you to do is learn just by the availability of data, right? So, there's copious amounts of sentences that we've said to, our kid. And at some point, his neurons are able to put those together and extract meaning out of it. And so that's what we modeled in computers. And then we had the next generation of conversational AI that can support messy language. We've still experienced a bit of a stagnation though. So what makes a conversational AI good? I mean, you look at Siri, Cortana, Alexa, and so forth. And much of that experience and that go-to-market is really characterized by the graph to the left here. When Alexa launched, everyone I knew bought one and was playing with it, was talking to it. And now we see that not as many people are using it on a regular basis. And really the technology has plateaued. It turns out that in the market, when your conversational AI is doing well, you would expect to see a graph much like you see on the right. And it turns out that groundbreaking innovations that go beyond what you see a Siri, Alexa, and a Google Assist using today is what produces this kind of engagement. You know, we see month over month, the number of folks using the experience is increasing because their habits are starting to change. It's easier and more frictionless to use conversational means to solve certain problems than it is. And you know, this has had impact. We see many, many companies bringing conversational AI to market. And this is companies that, you know, the kind of technologies that I've built and we've built with PhD students has actually had an impact in these organizations. Now, this is all chronicled. I have a book called Breaking Bots, and this is a really good treatise to the journey of creating a disruptive technology alongside the incumbents such as Apple, Google, Microsoft, Amazon. And how can a very small group of people build something that can beat the giants out of accounts like this? But what I really want to talk about today is a key observation, right? So ever since 2015, you know, we've been practicing in creating and disseminating this kind of technology, conversational AI chatbots, and so forth into market. We've got millions of users that have used the creations that we've made. And there's a key observation that emerges. The hardest part about creating compelling experiences in this space, successful experiences that can contain the calls that many businesses want to contain, or just keep users engaged and well-served. The biggest challenge is in the journey of training it at the particular use case at hand. So a lot of folks have shown great demos of experiences, but when an enterprise like a Barclays or a US bank wants to create a conversational AI for their customers, it turns out that they have a particular set of capabilities they want these bots to handle. And it takes about 12 to 18 months to take a off-the-shelf product like Dialogflow or, you know, IPsoft's Amelia or any of the big nuances, Nina, and any of these big platforms, and build an experience that they can launch to production. So it's really long, and this is after they know what they want to build and they've already procured the platform to build it on. It takes about 12 to 18 months to get that production ready experience. It ends up being incredibly expensive because they have to have teams of 30 or more technical folks that are collecting training data, training the experience, you know, getting it to do a good job at the kinds of topics that these conversational experiences cover. And so you require this talented ML experts. It turns out that to get these experiences not to break or not to be so brittle, it's all about the data you use in training these experiences. And there's a lot of nuances with how you use that data to get the AI just right so that it's really smart. And it ends up being an incredibly expensive journey, and it's high risk. I mean, I'll tell you, Erica by Bank of America took them multiple years, and they had a team of 200 people build the first version of Erica. And the first version of Erica was not that great, which is crazy, right? Like, that's a lot of spend. And then you end up with this experience that, frankly, the executives at Bank of America was somewhat unhappy with. And so it's high risk, right? You can actually have something that doesn't deliver on the promise that you set out to do as a company. And so there's this wall that many institutions have hit, and you've experienced it if you tried to interact with a conversational AI and it's not that good, and it's by Verizon or it's by a big organization, it's not for a lack of investment or attention. It really comes from hitting a wall. Now, there's a couple of walls that I'm going to talk about, and it's correlated to what I call one of the biggest misconceptions in the market. And this is a big one. It turns out that the technology we use to build bots is by and large very similar. And I have a diagram as to exactly what that looks like. Like, what is a conversational AI? What is a chat bot from an architectural standpoint? I'm going to show that. I think it's in the next slide or the next two slides. But a bot is not a bot is not a bot, right? It turns out that, you know, if you have a conversational AI that needs to help you figure out how to use a product or the feature set of a product, that's very different than a conversational AI that you would use to fill out a mortgage, or conversationally do your mortgage application, or conversationally order a pizza. It's a very different kind of problem. So there's a taxonomy that I've thought about, and I've thought writing about. I'd love to prototype this with you guys. And it's a taxonomy of bot problems. I call them information sharing bots, info bots, and the auto bots, the process automation bot. Very, very different needs. For instance, your pizza ordering bot needs not know that much stuff. It's got one task for you. Make sure I get this pizza order right, and then get it to your house. So it doesn't have to be an expert on the world. It just needs to be able to do that one thing very well. But an info bot may need to be an expert about many things. For instance, if Microsoft launches a bot about their Microsoft Office product suite, imagine the space and the diversity of questions such an experience might need to handle. Everything from, oh, well, I got a typo in Word and you got this new interface with like buttons that I can't even reason about. Why are you diverging from like every other program in the world has like a file menu? You've got these weird icons. Like, that might be some information. That might be the start of a conversation to get information. And that's very different than, transfer money from account A to account B. If you have a bot that just needs to do that, it doesn't need to have that much information, but it needs to get that transfer right. So that's a process automation bot, right? An info bot would be all the information about Microsoft Office. It's a lot of stuff. An auto bot would be help you transfer money from A to B. And just do that one thing for me, automate that process. So that's the taxonomy. I call them infobots and autobots. Now, one of the biggest challenges is what I call the skyscraper pitfall. And that is, in markets, especially in conversational AI, if there's a new company that comes out, that company is tasked with innovating, right? That company needs to create a chatbot platform that really does everything that everyone expects, and then differentiate themselves a little bit. And so it's a skyscraper. Everyone's building pretty much what everybody else has, but then differentiating themselves with something a little different, something a little better. And so you end up having this foundation as to how to do things that ends up looking the same, right? So they're all using the same fundamental architecture. And I described the infobot versus autobot, so I'll go faster because I feel like I'm gonna run out of time if I keep going at this crazy pace. And I'm a professor, so I talk a lot. But yeah, what is and isn't an infobot? So get information about the products and services, onboard users on how to use a product or service, or navigate to find something out conversationally, to learn something, that kind of conversation versus opening an account, filing an insurance claim, or ordering a pizza. So those would be autobots. This is essentially the architecture of pretty much all bot technology today, by and large. There's intent classification. Everybody's heard of that. Basically, what are your intents? Can it recognize your intents? Give me all of the various intents. And then once I know what the intent is, I'm going to extract the entities. And the entities are the parameters. So my intent might be change my pizza order to a Parmesan bar. And then it's like, well, what toppings do you want on the pizza? Oh, and put certain toppings on the pizza. So you need those variables, you need those parameters. And so for that need, you've got to extract the entities, right? So this intent entity dichotomy is essentially how chatbots work today. And most folks are building on top of this paradigm to deliver a new chatbot solution. But this is an Autobot paradigm. And we've got to break the mold for infobots. And I'll tell you very concretely, I have this crazy statement that it's impossible. This last bullet on the right, building infobots with Autobot tech becomes impossible. Impossible? Why say impossible? Well, it's actually impossible to use an intent approach to scale information. Because what happens is, when you add a new intent, you have to get a data set so that the bot can learn how to recognize that new intent. Every time you get a new data set for an intent, the amount of data you need for all the intents increase. And then the work to make sure that none of the existing intents data overlaps with your new data intent is added. So you have an exponentially growing amount of work for every new intent that you want to add to this information bot. So as when you hit 200 intents, for that 201 intent, the one more intent, you have to revise all 200 existing intents to make sure the data is clean. And then you also have to actually increase the amount of data for each intent, because that's how the neural network capacity works, right? The amount of data you need per intent increases with the number of intents you want to handle. So you hit a scalability wall. There's only so much information an intent bot can have. And so you can use Autobot tech for that. So what's needed? So we need to think different, right? And thank goodness the scientific community, the machine learning community, has developed interesting innovations in the last literally 2 years, like fresh off the presses. And I'll talk about that. So we went from rules to deep learning, good. Then we were able to support much messier language. You don't have to say things like a robot and get the grammar just right. You can speak freely and it can still understand. But now that we want to expand the knowledge of these bots, we have to go to another kind of model. And this is one of the big innovations that literally was published in 2020 and has become interesting from an academic standpoint in 2020. And we're now starting to see some innovation in market. And I'll call it zero shot, one shot, and few shot learning. And we'll talk a little bit about what that is and how that works. So I'm going to get nerdy for a minute, so bear with me. There's been a crazy journey with deep learning stuff, right? And I'm going to try to really tie it in so that folks that may not have followed the details on this know what I'm talking about. So deep learning is interesting. You got these neurons, and it looks at the words, and then the neurons fire, and then it makes predictions like what intent it is. Is this word relevant to a parameter that I need, like which account to move money from? So that's great. But then we evolved to have this new kind of model called a transformer model. And a transformer model has an incredible amount of capacity. And the beautiful thing about this kind of model is that it's incredibly good being trained in a way where it learns about the world, and then it can apply that learning generally. So GPT-3 is one of the most popular incantations of this. And if you haven't heard of what GPT-3 is, everyone's heard of Elon Musk. And Elon Musk made a $1 billion investment into an open lab. It's called OpenAI. And OpenAI was tasked to invent cool stuff for the world. And it'll be open and free for everybody. And so he paid $1 billion to create that company. They created GPT-3 as one of their biggest, it's probably the biggest contribution they've made yet. Of course, we are in a capitalistic society. So very quickly, after OpenAI created something interesting that created value, Microsoft came in and invested another $1 billion, and now there's a license agreement, and now it's for sale. So that's great. Thank you, Microsoft, for that nice contribution. So now you can actually pay for access to GPT-3 and utilize this model as an API. But this model is very special, right? Because this model was trained on the internet, right? So there was a slightly processed dump of the internet, the entire internet that this model read, right? And so it read the internet, and it has something called a self-supervised training task, jargon, that allows it to learn deep things about not just language, but about our world, right? And I'm happy to talk more if there's like super technical people that want to go deeper. Dude, I would love to go deeper. But it's special because it was trained, it took $4.5 million to train one time by OpenAI. They got the money because thank you, Elon Musk. And it's done some phenomenal things. Now, the cool thing about this kind of tech is that you can ask it questions about the world and it understands just about anything the internet knows. So people ask it, like you can have this thing take the SAT and it scores highly on the SAT. And you can ask it general questions. This model can write news articles for you that you wouldn't be able to tell isn't real. Just Google GPT-3 and what articles it's written, read it, and your head will explode if you haven't seen it already. But one special thing about this model is that it has a capacity to be told to do things that it's never done before. So if you wanted a conversational AI in your particular use case, you would be able to take this model and learn from the internet and have it solve your use case with the knowledge of the internet behind it. So this is an interesting kind of model that can create new types of pipelines that go beyond intent and entity extraction. Another such interesting model that I would point anyone who's building stuff to is something called Flare. Flare doesn't get as much attention because it comes from Berlin, a really brilliant research group. But by the way, their work is probably some of the best for industry application. If you wanted to take a model and like build real solutions with it, their particular contribution here is something that is quite special. So this allows for zero-shot intent classification. That is, you don't have to train the intents anymore, right? Or one or three examples is sufficient to get it to work for an intent. And so I would encourage folks to take a dive into this if you're building stuff. But if you look at the model at the core here is also a transformer model. So at the top of this picture, I have a transformer model. This is the new kind of neural network. Frankly, you cannot publish a paper in NLP sphere today that's using an LSTM or some of the previous buzzword models you might have heard. Transformers is actually what's becoming the accepted mechanism for doing deep learning in NLP. There's a couple of reasons. I can go on all day about it, but one of the reasons is it takes great usage of GPUs, but also captures the interrelationship of words in a sequence. It turns out that there's a lot of words you don't have to pay attention to learn something interesting about a language. This model is built so that it'll learn that. It can learn that as well. It's called attention layers, self-attention layers. But this is Flare has some ideations as to how you take that neural network guts and you can apply it in a zero-shot, few-shot way. Last one, another get more nerdy, bioencoders, right? This also is based on transformer model, but it gives, and I'll go to questions. I think I only have like 2 more slides. It gives a different view that's particularly good at information retrieval. That is, if you wanted to take a whole book or a whole encyclopedia and turn that into a conversational AI that you can really have a conversation with that book or encyclopedia, this might be the kind of neural network that you want to use. So I've got to talk about Joseki. So based on a number of these learnings, not just about the kind of AI that we need, but also about how we develop software and end-to-end solutions for artificial intelligence, has kind of come to a head in the creation of this open source technology stack that I've led with a number of brilliant folks, the creation of. And so you can check it out at https://joseki.org. It's wildly different. We're writing many papers on it. There's already 3 real products, production products that are built on it. And it's available to everyone. So feel free to engage, email, and so forth. And finally, I'd love to just point out that what has allowed us to thrive is tech. We discovered technology in this spike. Space travel and computers came when we were like close to 4 billion people. Then the internet and now AI. Innovation is what's going to allow us to continue to thrive. And I want to encourage everyone to be thoughtful about how technology and how innovation can be utilized for the continued thriving of our species. And so with that, I'll take questions. Hopefully I'm not over time.
No, we're good. Yeah, if anyone has a question, just please go ahead and ask.
Keelan, feel free. Yeah.
Oh, Jason, I was just giving a little round of applause, but
thank you, thank you.
If no one else has a question, I guess I'd just be interested in hearing a little bit more about your ideas about how we will get to be able to develop infobots and what is the path towards getting there.
Yeah, no, that's a phenomenal question, right? It's really about how do you envision a world without intents, you know? And so one of the ways, so there's a project I'm involved with, it's called Zero Shot Bot, where we treat the conversational building experience as an information retrieval task, right? So you can actually have these generalized self-trained models that really understand something deep about the language and the world, be able to, given the task of selecting, if I was to give you, let's say, Keelan, here's an example of how this tech works. Keelan, a non-intent way to think about the world. If I was like, look, you may not know a lot about cars. I'm just making that up. But here's like seven answers that these are the answers you can give people. And I'm going to let strangers come and ask you about cars. At super technical answers. The carburetor is responsible for blah, 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 and whatever, right? Your neural network in your head could probably identify the right answer to a question, even though you haven't been trained specifically in cars, right? So we would call that a task. So the task is of a space of possibilities, which one do you think might be best given your generalized knowledge of the world and everything you've seen in your life's journey? And you would be very good at that task, right? And so that is a formulation of an information retrieval relationship. And actually we've built that into the way Zero Shot Bot works, right? And so the journey for Zero Shot Bot, it's free, by the way. Everybody could just go build stuff on it, zeroshotbot.com. But the journey for Zero Shot Bot, you just log in and you just give it a space of answers, and it works incredibly well. For instance, like you could give it an answer, our milkshakes don't have real milk in it because that might make people sick. And you could say a question like, hey, I've got celiac disease and I'm really nervous about eating at your restaurant. What do you got for me? Enter. And it, out of like 100 answers, it'll identify the milk answer, even though there's no keywords, there's no trained data. It's gained that perspective on the world from this self-supervised task of reading Wikipedia and the internet and so forth. So that would be one example of a non-intent-based methodology for building chatbots.
Very cool. And if I may ask a follow-up question, do you think that a chatbot or an infobot trained with that approach is ready for a robust production deployment with all the types of things that users might ask? Totally
good question. What we found is absolutely right? And so there's a couple caveats, right? So you'd be surprised, and it's really about how you formulate the scope of the task. So what we found is that works incredibly well across many domains, healthcare, and we're talking about the same pre-trained model that has a self-supervised general task, being able to just predict what is the right response out of possible responses. that actually works incredibly well, and you could actually try it out. And we actually have a number of companies that have deployed this, right? So we've got eGenera and Alternate eSource. These are like IoT real companies that have brought this technology in, built chatbots with it. And in the eGenera case, the cool thing is you can build the chatbots instantly because there's no training. There's no training time and tuning. So you give the answers, and they were able to, for the first time without having a human in the loop, provide enough information about a product that someone could buy it. That was a week after having access to the zero-shot bot tech. So we've got a number of demonstrations of it working for real commercial use cases. But it's the tip of the iceberg, right? There's so much more that you can do. There's actually zero-shot methodologies for extracting the relevant parameters that you might need, right? So you can have this multi-turn kind of experience, like this sophisticated Autobot style process type of experience without having to train anything. TransZ would be one of the technical papers I would point people to as a starting point to understand how you might be able to do zero-shot slot extraction, they call it, or entity extraction. Yeah.
Cool. Thanks a lot.
Anytime.
Thanks so much, Jason.
Awesome. Thank you all for having me if there's no other questions. Thanks.